In this video, we're going to look at putting the substitution rule into practice on an integral that is made up of a composite function. And just recall that composite functions are of the form f of g of x. So there's an inner and an outer function. In this case, you can see that the inner function is x squared plus 1, and the outer function is that inner function raised to the fourth power. So we're going to go through a little bit of a process here, and I'm going to stop and start the recording so that you don't hear all the clicking from my stylus, but bear with me. So we're going to let u equal the inner function. So u is going to equal, oops, erase that. We're going to let u equal the inner function. So in this case, u is going to be equal to x squared plus 1. And then we're going to take the derivative with respect to x. So du is equal to 2x dx. So that's your second step. Take the derivative with respect to x. With respect to x. Then we're going to solve for dx algebraically in the above equation. So dx is equal to du divided by 2x. Then we're going to make substitutions for u and dx into the original integral. So we're going to make substitutions. For u and dx. So let's look at the original integral. And make the appropriate substitution. So this integral is going to become, I'm going to rewrite this slightly. I carry the 2x. There's nothing to substitute there. There's a u raised to the fourth power, and dx is equal to du over 2x. Simplify this algebraically, and you see that the 2x's cross out, and this integral is simply the integral of u to the fourth du. Much easier integral than working with the composite function, because now we can simply apply the power rule to that. So applying the power rule, that integral evaluates to u to the fifth over 5, right, plus a constant. So basically, you're just taking the antiderivative. Okay, so you're taking the antiderivative. And then we're going to substitute back for u. All right, so that really was step 5. Take the antiderivative. And step 6, we're going to substitute back for u. I'm going to have to find a new option for my style. Substitute back for u. And when you do that, you get x squared plus 1 raised to the fifth over 5 plus a constant. So that's your answer to the original integral.